So what am I here to talk about today? I'm here to talk about, why do we use this Kubernetes thing? Why is it so popular? Why is everyone, so interested about deploying containers or using containers for, machine learning or web applications? So, but before we dive into that, let's have a look at a little bit of a background, right? What do we do and when we deploy applications? Well, back in the days, right, we used to have large applications, right? And we used to build these large applications, but in the recent past, what happened is we basically decided that it was a much better idea to just break these large applications to smaller components, and each component would have a single focus. We will have an API, a front end, and each of those would be independent, right? And we thought it was a good idea because we could have quicker deployments, right? Everything would be separated, and we could be released independently. We said, each team could work on a single feature, so that's a good idea. And it's also overall less risky, right? Because if a component goes down, it's just that component. It doesn't take down the entire system. And as developers, we said, this is a great idea. We should keep doing it as much as we can. However, there is something else going on, right? So there is, some of us who are perhaps more into the infrastructure side of things are seeing these kind of things and thinking, well, it is great, but when I have a single application, then I could just bring that single application and put it inside a box, and that would just run, okay? But now we don't have a single entity anymore. We have, these individual components. So we should run each individual component in its own box, right? What we call virtual machines, for example. But the reality is that as developers, we don't just break things in four. We tend to be, a little bit more, we take things to the extreme sometimes. And we end up with a lot of applications. So a lot of applications, actually, they introduce quite a lot of challenges on the infrastructure side of things. And if we look at some of the challenges, the first challenge that we can think about is, when we had these computers, right, these computing units, then those tend to be quite large computers that could run a lot of things, right? And if you look at the ratio of things that were using the operating system and the space which was usable for you for running the application, there was a tiny bit the operating system was using a tiny bit, the rest you could use yourself. Now, if you had only a few applications, then you would have this split, and overall, the memory and CPU used by your operating system will be a tiny bit, right? So if you think about it, 2 to 3% to run the operating system, it's okay, right? It's very small. But when we switch to something like smaller components, and a lot of them, what happens is we tend to run smaller applications and smaller virtual machines. And the ratio between what is used by the operating system and what's used by your application, like your web application, changes quite a lot, right? So we're seeing some shifts from 2 to 3% to more than double, from 6 to 10%. And if you think about it, if you have a bill on GCP, for example, of $1,000, then you're spending $100 in running operating system. So some money that you will never see back, right? It just lost. The other challenge is usually when we build this application, we used to put this application inside these boxes and everything will be fine, right? We will have another box and another box, and if the application was smaller, then there would be just a little bit of gap, right? Which we couldn't utilize. And it was still okay. But now with this application that we build, which are much smaller, much focused, right? Compared to what we had before, we have all different shapes and sizes. So if we deploy them in these boxes, then there is a lot of white space, right? Which we didn't have before, and now we do, which is kind of a problem. And the last sort of issue that we get, that we inherit from this sort of development that we do, is that, yes, all these microservices, we like to pick languages, do we? Okay. But it turns out that we really, really like them. So if you go and look at this, microservice architecture, or if you go in a company, you will find that someone is writing in Go, someone is writing in Node.js. There is, I'm going to say some legacy in Ruby, but I don't want to offend anyone. Okay. But more in general, is we have a lot of applications, right? Different languages. But even if you are in one of these companies, really rigid, saying we do just Java, okay, really serious. they still have the same problem, right? Because they have different runtimes. It never just matches the same. So even if they pretend to be better, they are not. Okay. So what can you do? That's one solution. Okay. But let's take a step back, right? So we talked about some of these problems were originated by ourselves, right? So we picked these boxes, we call them virtual machines, and we place stuff inside. But what if we change the story, right? What if instead of starting with virtual machine, we started with something else? So it turns out that in the meantime, there were some features in the Linux kernel that they were quite interesting. One of these was control groups, which is basically when you launch an application, you can define how much memory and how much CPU that process is going to use. Okay? And then you can limit things like memory and CPU. And then the other things you can do is you can launch a process like your web application, your binary, and you can also set isolation. So what a process can see. Can it see other processes? Can it see network packets from other processes as well? So we just, designing boundaries around our application, what kind of things it can see and how much memory it can use. It turns out that this sort of stuff is quite interesting. And someone said, what if I combine three things? These control groups, namespaces, and a little bit of magic, okay? And they came up with this, right? What we call Dockers, what we call containers. So just a way to launch a process which has got some extra memory and some extra namespaces just to set isolation and groups. So generally, we don't say this, but let's say for the sake of the point we are trying to make, but Docker containers look like lighter virtual machines, right? Lighter boxes that we've seen before. So if before we had this, right? So we had the server and several virtual machines, several boxes inside. Now we basically, if we run containers, then we don't have these boxes anymore. And then we can run the infrastructure much more packed, right? So everything is neatly organized together, which is good. And the other benefit of these containers is that because these are just processes where we set limits, right? It's not slow as a virtual machine. I mean, you must have run VirtualBox and waited, gone for a copy and come back and still there, booting. And there is no hardware emulation. This is just launching a process in the same way you launch your IDE, right? So that's the same thing. A Docker container is the same thing. And then the best part is that when you launch a virtual machine, it's going to pre-allocate some memory, right, and CPU. When you launch a process, it's just going to use the memory dynamically. So these Docker containers are basically just double-clicking on your IDE. And then the third part, which is also quite interesting, is that these Docker containers, at the end of the day, what they are just archive, like zip archive. And what they contain is not just the code that you run, but all the dependencies. And dependencies, if you're running, for example, a JVM, is going to be the runtime. If you're running Node.js, it's going to be in the Node.js binary. If you're running Ruby, it's going to be the MRI. If you're running Go, well, you don't need any of that. It is just a binary. So we combine your runtime or your files all together with any other dependency you've got, and we just wrap them up in a zip file. And we call that zip file container. Okay, so that's the magic of containers and how they work. But the powerful thing is that if you think about it, in the past, right, if you had to deploy anything like a Ruby on Rails application or Node.js, you would need to go to someone else and say, hey, can I have a box? Can you go inside, install a couple of binaries, blah, blah, blah. And if it was just one, that was fine. But when you had like several applications, it becomes really, really complex, right? This server needs to have Node.js and Ruby and so on and so forth. But with Docker containers, we don't need any of that. Because we wrap everything inside a container, we don't care what they look like from the outside, because they are just containers, and we can just deploy them as containers. So containers are great. I hope you share the same feeling. But the thing is, if we have a lot of virtual machines and we switch to containers, we still have a lot of containers. Okay, we haven't solved the problem on how do we use these containers. So it's Christmas time. Okay, so I have a couple of wishes. I'm going to have a wish list with some things I want to solve this problem of containers. So the first wish I had what if it could be something that could manage all of these containers? And it could be something that ideally, I don't need to go there and manage servers. It's just going to take everything. It's just going to take care of everything for me. So it's going to basically look at all of the things I've got and just make a single bundle. Okay, so I don't need to worry about where these applications that I build are going to end up. And then ideally, I want to also make sure that this is something that I can program, because I'm a developer and I like to write code. Okay, and you might have used some of these tools in the past. So it turns out that these technology that manage several containers and have got these properties are called container orchestrators, and the market has got a bunch of them. Okay, so you might have heard of these ones, but another example is if you're using AWS, it's called AWS ECS, which is the container orchestrator. It's not a fair fight. Okay, so Kubernetes is de facto the container orchestrator. Okay, so this is a fairly old graph, but the trajectory is, you can see the trajectory of Kubernetes. And so why this Kubernetes? Why is it so popular? Well, one of the reasons why it is so popular is because you don't need to think about your servers, right? You don't need to think about this computer that you have to deploy your applications. What Kubernetes does is you install it on one of those. The other nodes inside your infrastructure will join the master node. And what happens is the cluster is just going to absorb memory and CPU of all the nodes. Okay, and it's going to become like a massive computer, just a single one, which is much easier for us. We only deal with one single computer. The other interesting thing is about Kubernetes is that it's quite clever, but clever is not the right word. It's quite nice Tetris player. So if you think that these boxes that we created, they come all different shape and sizes, right? Kubernetes, what it does, it usually play Tetris with your infrastructure. As more containers come in, Kubernetes will just find the best slot to place your containers, right? Until the end, you get something like this, which is great if you like Tetris, and it's also great if you like, efficiency, because as you can see here, we're trying to maximize the space that we can get out of our servers. And then the last one, again, I'm a developer by trade, so I like to program things and change things. So everything you do in Kubernetes is just an API call. Okay, so you've probably seen, this is a curl request, and I can query the API, and I can query, the application that I deployed. And then there is also documentation, so I can just read the documentation and create more endpoints. So if I want to create an application, I can just say curl, create an application. Curl, create another node. Curl, provision a load balancer. So everything in Kubernetes is just an API call. And that's why it's so cool. So, do you believe me? Or I just made up everything? It's demo time, okay? So before we do the demo though, just a quick description of what we are trying to do. So ideally, this is what we want to build, right? We want to build the red pages that people visit, okay? That's what we do all day. However, sometimes these red pages, they become super popular, right? So we need 2 copies instead of 1. So what do we do to distribute the traffic between the 2? I hear load balancer from the crowd. Very well. Now, we might have more than one application because hopefully, where we work, they don't have like a single product or a single microservice. They probably have more than one, like this. What if I want to route the traffic to both microservices? How do I distribute the traffic? I hear a load balancer from the crowd. Not really, but that's the thing. Okay. So we have 2 layers of load balancers when we want to distribute the traffic between several services in our infrastructure. So we have an external load balancer, and then internal load balancer, and then the applications. So in Kubernetes, we do exactly the same thing. We just like to call everything with different names. Okay. So instead of calling the internal load balancer, we call them services, because in computer science, that's a very specific term, the service. And then instead of calling the external load balancer the load balancer, we call it the ingress. Okay, this is a little bit more specific, thankfully. And why calling the application or container containers when you can call them pods? So that's how we call them. Okay? So that's basically how we deploy application in Kubernetes. So let's have a look. So we discussed about three different things. We discussed about the ingress, the service, and then our pods. So the way it works is, first of all, we create a container. Yes, correct me. So a container, what it is, we usually create container from a list of instructions. So the list of instructions is usually called a Docker file, and this contains basically, it's like a glorified ISO in VirtualBox, right? You say, I want to start with Ubuntu, I want to start a couple of things, and install my application. That's the same thing we do in containers. In this particular case, I built a Hello World app in Go, and just packaged it inside a container. Then I can build a container with Docker build, -d for the name. I'm going to call it hello, and then hopefully it will not let me down. Okay, so this is going to take ages, and we can move on. So what we do when we have this container, then we just define how we want to deploy it. Now, everything we do in Kubernetes, we actually write this very nice YAML file. Okay, so just a description of what we want the end product to look like. And what the end product will look like is a single application. Okay, what's the name? Hello World. Oops. And what's the name of a container? Okay, it's called demo. I built the wrong one, but you get the idea. We're basically just describing what that should look like. Then we have the service, which is the internal load balancer, and the ingress. If you think it's a lot of YAML, yes, it is a lot of YAML. Kubernetes engineers are usually called also YAML engineers, because that's what we do all day. Okay, so once we have those, then I have a cluster running locally. Oh, by the way, this is just created a container. It's local. So when we have these resources locally, then what we do is we have a cluster, right? A Kubernetes cluster. In this particular case, I'm running a local cluster called Minikube, which is running on my machine because I was afraid that the internet would not work. And usually what we do is we send these YAML files to the cluster. The cluster will read it and then create the resources on our behalf. Now, to send these instructions, we use a command line tool called kubectl, which everyone pronounced with a different name. kubectl, kubecontrol, I say kubectl. And then we say apply. And we just send resources. You can see that when we create these resources, then the resources are, we submit the request, but it doesn't wait, right? It's just going to return immediately. But in the background, what happens is Kubernetes will go and create these resources for us. I can see hello world here, and then the ingress. Okay, so I can see that it created all of the resources. Can I see my application? Hopefully it's going to work. Yes, I can. Okay, so that's the application. So you can see CKFGD. What is that? CKFGD. Okay, well, good. Now, the good thing is about Kubernetes is that we generally have a single application, but that's, we like things to scale. So generally what we do is we scale the number of replicas and scale the number of instances of our application. And the way to do that is by writing what we call a deployment, which is what I just showed you. Generally, the reason why we use deployments is because in Kubernetes, when you create a deployment, then the deployment looks after your pods, right? Looks after your application. And if one of those applications were to go down, then Kubernetes will bring it up. Okay? So let's have a look at this one quickly. So what I can do, I can go in my deployment and I can change the number of replicas, which is the instances of my app, from 1 to 5. And I can see there are 5 new applications running now. So what if I go and delete this one? Ooh. Then I do a get pause. There are still 5 running again. Okay, this is because as one is deleted, Kubernetes will replace it with a new one. Okay, so it's doing a lot of stuff for free for us. Okay, but one of the things that we do very, very frequently when we deploy application is we deploy an application and then we have a better version. Okay, we deploy version 1 and then a couple of days later we just find a way to refactor everything, right, and redeploy it again. Now, Kubernetes is quite interesting on this space because it automatically does what we call a rolling update, right? It's going to do an upgrade of your application with 0 downtime. So how do you do that? Well, if you look at this particular deployment, we have 3 applications with a red page. So when you say I want to upgrade from version 1 to version 2, this is what happens. Kubernetes will create a new version of the application, okay, and will replace it with the old one. Create a new one, replace it, create a new one, replace it. Okay, because it's doing it one at a time, then the traffic never goes down, right? We never had downtime. So let's have a look at that as well. So what I should show you before we start is that the application exposes a version. Okay, this is version 1. So what we can do hopefully this is going to work. Nope. Oh. I'm pretending this is normal, but it's actually not. So bear in mind with me. I've got version 1. You can see version 1 running. Okay. So what I do next, I'm going to go and change these from version 1 to version 2. What would you expect to see now? Is this going to continue to be 1 all the time? What's your guess? Is it going to go to 2? Yes, hopefully. I guess. Hopefully it works. So the way we check that is we do a kubectl apply -f. Okay, and then switch back to the sleep, and we see what happens. Oh! More 2. 1 and 2. 2, 2. Okay, eventually it's going to switch to 2, right? And you can see now the whole traffic is going into version 2. So we just did a rolling update by just changing the version of the application in the specification. And that's basically, Kubernetes did a rolling update for us. Where is my mouse? Okay. So that's basically why everyone is so excited about containers and Kubernetes. It's quite easy to create deployments. It's quite easy to do rolling updates. And because everything is encapsulated, it's very easy to scale to several servers as well. So who is using this and why? So I think a good example of who is using Kubernetes for the sort of large-scale processing is this company called OpenAI. So what they do is, back, I think 2 years ago now, they used to train machine learning models on Kubernetes, and they had like this, what we call now medium size, at the time was really large size, with 2,500 nodes, okay? And then what kind of things they did, they installed basically something designed to scale the system, right? So when the application needs to train more models, then it will just create more instances of this model and will just, process more jobs. And then that was combined with another thing in GKE, which is the cluster autoscaler. So when you run out of space, like in this case, it will just create more nodes and then keep doing this training of models. So it turns out that they were building a model to play Dota, which is quite cool. And I don't know if you heard the news, but I think this year in July, they also managed to compete with pro players as well. They run for competing with pro players, they run much larger cluster. We're talking about more than 5,000 nodes per cluster, so it's very cutting edge stuff. But at the time, the reason why I'm mentioning this is because at the time, they basically shared what kind of configuration they had for their own cluster. And this was the configuration for the 2,500 nodes. So you can see that they used 256 P100, which I think are TPUs, and a bunch of virtual CPUs. This is everything in Google Cloud, everything on GKE. Can you guess how much money is this per hour? No? Well, it turns out that it's not a lot. I mean, it is a lot. I mean, objectively, it is a lot. So we're talking about US dollars here. So it's probably $1,600, close to $2,000. But if you think about it, you're right. If you're a student, well, if you're a student, it's probably going to be too expensive. But if you're a small research center, right, you have access to so much power, right, which normally would be just for large corporation or large companies. Now you can go in GKE, click on 2 buttons, provision a 5,000 node cluster, pay $2,000 for an hour, and just take it down. This is unprecedented, right? We never had such ability to create things so quickly and destroy them. Even if you're sitting in your room, back home, just mining bitcoins or training models. So I think this is pretty exciting. It's pretty exciting for me. So that's everything I wanted to show you today. I hope it was 20 minutes. I got more or less. So we talked about microservices, how things have changed since from where we started, right? From these monoliths. We talked about these containers as lighter VMs, so just processes that have got memory and CPU limits. And we talked about Kubernetes as one of these container orchestrators. Okay, so that's everything I wanted to show you today. Yeah, I think we usually run workshops on this kind of stuff. We have one coming up the 27th of November, but the reality is that we're going to do a repeat of the Zero to Kubernetes course, which we have done in September, and we're going to do it in December. What we're going to do in this session is we're going to do the same 3 hours. We're going to go through building an application in Kubernetes and deploying it. Okay. So last time was quite popular. I'm not sure about this time, but yeah, I think if you're interested in this sort of space, it's on the 7th of December. I think on a Saturday. So join me. And I hope you enjoyed it. Thank you very much for listening to me.